Hello, this is Cal. Today I'm going to show you how to use the energy meter to realize zero export function for Deye 3-phase stream inverter, and this one is Deye 3-phase stream inverter. And as we can see, it has three sets of PV input. And this one is the DC switch. This one is the RS485. It used to communicate with the energy meter, and this is the A, the white cable. The black one is the B. This one is the grid output terminal. And this one is the CHNT 3-phase smart meter. Here's the diagram of the energy meter. As we can see, 147 is for the load connection, and the 3669 is for the grid connection, and the 2428 is for the RS485, and the 24 is for the A. And here is the system diagram. As we can see, here is the grid input and the output, and the output to connect to the inverter AC output terminal. And also here is the communication cable to the inverter RS485 terminal, and also here is the terminal 3 is connected to the RS485A, and the full port is connected to the RS485B. And let's move to here. This is for the circuit breaker, is for the grid input. 3-phase. Okay, let's show its voltage. Neutral line L2, L3. Okay, so phase to phase. And then it comes to the energy meter. Here, coming to the energy meter, and then energy meter, from the energy meter comes out two sets for size wires. One is connected to the inverter AC output, and another is input to the load, the three-phase load. And also, according to the diagram, 369 is for the port, is for the grid input. Output to port 1, 4, 7, and 10. 10 is for the neutral. And here is for the input. Input 3, 6, 9, 10. Yes, for the input. We need to make sure the sequence is right. Otherwise, the inverter can't realize zero export function. And let's go here. As we can see, the load power is 4.17 kilowatt. Here is the load power. Okay, let's move to the PV power is 2,800 volts. Okay, let's write it in here. Here is the PV. Okay, let's see the meter power. The meter power is negative 1.3 kilowatt. 1.37, 1.4 kilowatt is the meter. The meter power, it means from the grid. The grid provides 1.4 kilowatt to the system, to the load. So also we can calculate this one, 1.4, and plus 2.8. This one is 2.8 is equal to 4.1 kilowatt. So the PV generation will firstly to power the load, and the other energies come from the grid. Also, when the inverter has a good communication with the meter, it will show the meter power 1.4 kilowatt. It should be same with the energy meter LCD. Okay, let's see the meter power. Yes, 1.37 kilowatt. It's the same with the meter. Also, it will show the load power. If there was a load power, shows load power is 0, it means the energy meter input and the output cable is reversed. In this situation, you need a reverse connection for the energy meter input cable and output cable. So we can see on the LCD, it shows the PV power is 2,800. And the currently PV input voltage is 579.3 volts, and the current is 12.1 amps. Here is the grid voltage, A phase, B phase, C phase, and the frequency, temperature. Here is the meter. The meter power is negative 1.4 kilowatt. It means at this moment the grid is power 1.4 kilowatt to the system to power the load. Okay, let's move to the energy meter. See, here is the current, the B phase current, C phase current, and here is the power. The total power is from the grid. As we can see, also it's 1.4 kilowatt. It's the same with the meter value on the LCD. So it means the inverter and the inverter already communicate with the energy meter successfully. Also, here is the load power. Here is the load power 0.7 kilowatt. This one is the B phase 0.6 kilowatt. And this one is the C phase. The power is come from the grid. Here's the electricity consumed. Here's the power is input from the grid. Here's the power export to the grid. Here's the communication speed. Here's the communication address. Here's the voltage, current for each phase. Also on the inverter, we go to the setup. We need to check the communication address. As we can see, the address is 1, and the baud rate is 9,600. It's the same with the energy meter. Okay, I will show you how to turn on this function. Run parameters and input the default password is 1, 2, 3, 4. And let's go to the meter. Yes, already is on. When you set some meters, make sure you click here and then press the enter button to save the settings. Okay, now let's turn off the load and see what happened. Okay, I already turned off the load. Because I connect the there was a 3 kind of load on the 3 phase. Here's the load. We still have the 1.7 kilowatt. Okay, let's move to the energy meter. voltage. For the A phase is 0.6 amps. The B phase have the 7.7 Aprils. The C phase is 0.6 amps. Because the B phase and the C phase load are already zero. So in this case, the inverter stop output power. It shows zero. Okay, let's turn on the load on the B phase and the C phase. As we can see, the load power is increased. Okay, let's go to the PV power. Also, the PV power is increased because the energy meter detect the load power is increased and send this message to the inverter. So the inverter increased the power to meter the load